Okay, so let me see if I can write this, because I can't, I cannot seem to figure out how to write this, or use a screen recorder to do this, so I'm just going to do it the good old-fashioned way, by using a pen and paper. So, the question then is, where does that last digit go? This is so difficult. Okay, so if we've got 1/3, right? So here's 1/3. 0.3 repeating forever. 0.3 repeating forever. 0.3 repeating forever equals 0.9 repeating forever, not 1. Okay, so then we need to add 0. And this is where things get really weird. It repeats forever minus 1. So I don't really know how to write that. I don't know what the notation for that would be, but it would be like 0.0 repeating forever minus 1. Something like that. Because what happens is, let's truncate it. This worked pretty well. Truncating it makes it look a little bit cleaner. It makes a little bit more sense. So if we take 0.3 repeating forever to be basically 0.333, right? Then we can see where this decimal place goes to add the magical number. We have to add it here at the very last decimal. So where that is not actually, it's not actually this full amount, because this notation here, this is repeating forever. But if you were to subtract one last digit, because if I put another 0 here, then that would be repeating forever, right? Because it would be, at least for this truncated version that we're using, which is, analogous. So if I was to repeat this, we get 3 deep approximately. If I were to repeat this, we get 2 deep and then the 1. So it isn't quite repeating forever. It's repeating forever minus 1. So I guess you'd write it like this. It would be repeating forever minus 1. So that way it's, it repeats for every digit except the last one. And that's important because, again, if I were to put it repeating forever, just the way it actually is written, right? This would be 0.0 repeating forever 1. So I'm not actually accurate when I write it this way, because if I were to make this little analogation, an analogation, it's 0 repeating forever truncated to 3 digits, which is not the 10,000th place. Excuse me, I made a mistake in the last video. So you've got tens, hundreds, thousands. If we truncate infinity to the 1,000th place, 3 deep, then to put 0.0 repeating forever 1 is analogous to putting 0.0001, when in reality we need this one. We need 001, not 0001. And when we do that, then we get 1. Because if you add 0.333 plus 0.333 plus 0.333, then we get 0.999. And then we add this 001 at the end, and we get 1. Okay, so this, while it looks like it's 0.0 repeating forever 1, like I had thought, I've misjudged it. I was 1 decimal place off, excuse me. That makes all the difference in the world when we're talking about this stuff. It makes or breaks the argument, so it's not like it's a small deal. That's why I had to redo this. But the magical 1 number that goes in there, it has to go at the last decimal place. when you add that all together, then you get 10. And this gives us the 10, this term here. So it's not quite repeating forever. It's repeating forever minus 1, such that the last digit is 1. Not the next digit after an infinitude, but just the very last number of the infinitude.